So now student, we are discuss another example of Vogel's approximation method. So here given the market and plants demand and supply. So first we check our problem is balance or unbalance. So here find the sum of demand and sum of the supply. If the sum of demand and supply are equal, then the problem is balance type problem. If sum of demand and supply not equal, then the problem is unbalanced transportation problem. So here sum of demand is 25 plus 35, 60, 165, 185. And sum of supply is 50, 120, 150 and 200. So here sum of demand and supply not equal. So this is the unbalanced transportation problem. So now this problem solved by Vogel's approximation method. First we convert the problem to balanced transportation problem. So how to convert the unbalanced transportation problem to balanced transportation problem? So first we check the demand is less than or supply is. Here demand is less than the supply. So here we introduce the dummy column. Here given plant P1, P2, P3, P4 and market M1, M2, M3, M4 and value of cost cell is 4, 6, 8, 13 and supply is 50 and plant 2 is 13, 11, 10, 8, 70 and plant P3 is 14, 4, 10, 13 and supply is 30 and plant 4 is 9, 11, 13, 8 and 50 and demand is 25, 35, 105 and 20. Now we introduce dummy column M5 and taking the cost cell values is 0, 0. So now write here demand. Here demand is 15 less than the total supply. So write here demand is 15. Now sum of demand is 60, 165, 185, 200 and demand of supply is 120, 150 and 200. So first we convert the unbalanced transportation problem to balanced transportation problem, and after this process now we solve this problem by Vogel's approximation method. So same process we are discussing previous question. Here first we find the penalties of row and column, each row and each column penalty. First in first row here smallest element is 4. Smallest element is 0 and second smallest is 4. So the difference of smallest and second smallest is 4. And in second row smallest 0 and second smallest is 8. Difference is 8. So penalty is 8. And third row difference smallest 0 and second smallest 4. So difference is 4. So the penalty is 4. and next is smallest 0 and second smallest 8, so the difference is 8, so here penalty is 8. Similarly, we find the penalties of each column. Here in first column smallest 4, second smallest is 9, so penalty is 5, and in second column smallest is 4 and second smallest 6, so the difference of 4 and 6 is 2, so penalty right here 2. And in next column smallest is 8 and second smallest is 10, so the difference of 8 and 10 is 2, so right here penalty is 2. In next column smallest is 8 and second smallest is 13, so the difference of 8 and 13 is 5, so the penalty is 5 right here. And in next column smallest is 0 and second smallest is 0, so the difference is 0. Now we check the highest penalty. So here highest penalty is 8, but 8 is right in two places. So first we check the smallest element in, so now there are two options. First we choose this 8 and now allocate, and other case is choose this 8 and allocate. So we are choosing this 8 and in this row. Here smallest cost entry cell is 0, so now allocate here. Here availability of demand is 15 and supply is 70, so right we allocate here minimum of 15 and 70, so minimum of 15 and 70 is 15, so allocate here 15, so 15 minus 15 is 0 remaining and 70 minus 15 55 remaining. So now demand of market M5 is remaining 0, so cross out market M5. Now make the next table. Now reduce matrix is M1, M2, M3, M4, P1, P2, P3, P4 and 4, 6, 8, 13, 13, 11, 10, 8, 14, 4, 10, 13, 9, 11, 13, 8, and demand is 25, 35, 105, 20, and supply is 50, 55, and 30, 50. So same process apply here. First we find the penalties of each row and each column. So now in first row here smallest element is 4 and second smallest is 6, so the difference of 6 and 4 is 2 right here, and difference of, and in next row smallest is 8 and second smallest is 10, so the difference of 8 and 10 is 2, so penalty is 2. And in third row smallest element is 4 and second smallest is 10, so the difference of 4 and 10 is 6, so penalty is 6 right here. In next row smallest is 8 and second smallest is 9, so difference of 8 and 9 is 1, so the penalty is 1 right here. Similarly we find the penalties of each column. So in first column smallest element is 4 and second smallest is 9, so here we see smallest and second smallest same element in this column, so write as it is these penalties here. because we cross out the column. So the effect of penalties on row, but no change in columns penalty. So right here is 4 9 difference 5 and 4 6 difference 2 and 8 and 10 difference 2 and 8 and 13 difference 5. So same penalty right here. Now we check the largest penalty. Here largest penalty is 6. So in this row, check the smallest cost entry cell. So cost entry cell smallest is 4. So we check the availability of these 4. Here demand is 35 and supply is 30. So we allocate minimum of 30 and 35. So minimum of 30 and 35 is 30. So allocate here 30. Now subtract 30 from demand and supply both. So 35 minus 30, 5 remaining, and 30 minus 30, 0 remaining. So the supply of plant P3 remaining 0. So now cross out the plant P3. Now move the next table. So the reduced matrix is P1, P2, P4, M1, M2, M3, M4, 4, 6, 8, 13, 50, and next is 13, 11, 10, 8, 55, and in P4, 9, 11, 13, 8, 50. And demand is 25, 5, 105 and 20. So now we find the penalties of each row and each column we discussed in previous table. Similarly, we find the penalties of each row and each column. So in first row, here smallest element is 4 and second smallest is 6. So the difference of 4 and 6 is 2. So right here penalty is 2. And second row, smallest is 8 and second is smallest 10. So the difference is 2. So right here. And in third row, smallest is 8 and second is smallest 9. So difference is 1. So write the penalty here 1. Similarly, we find the penalties of each column. In column first, smallest is 4 and second smallest is 9. So the difference of 9 and 4 is 5. So the penalty is 5. So right here. And in second column, smallest is 6 and second smallest 11. So the difference of 6 and 11 is 5. So the penalty is 5 right here. And in next column, smallest is 8 and second smallest 10. So the difference of 10 and 8 is 2. So the penalty is 2 right here. In next column, smallest 8 and second smallest 13. So the difference of 8 and 13 is 5. So the penalty is 5. So right here. Now we check the highest penalty. So here highest penalty is 5, but 5 is right in 3 places. So here there are 3 cases. In case first, select any one in these 5. So first we select this 5. So for this 5 now enter in this column. So the smallest penalty of smallest cost cell entry is 4. So for availability of this 4 is demand is 25 and supply is 50. So the difference, so we allocate the minimum of 25 and 50. So minimum of 25 and 50. Minimum of 25 and 50 is 25. So allocate here 25. Now we subtract 25 from 25, 0, and 25 from 50, remaining 25. So the demand of market M1 is remaining 0. So now cross out market M1. Now move the next table. Now the reduced matrix is remaining M2, M3, M4, P1, P2 and P4. And cost of cell is 8, 13, 11, 10, 8, 11, 13, 8 and demand is 5, 105, 5, 105 and 20 and supply is 25, 55, 50, 25, 55 and 50. So again we find the penalties of each row and each column. So here the smallest element is 6 and second smallest element is 8 in first row. So the difference of 6 and 8 is 2. So the penalty is 2. Similarly we find the other row penalty. In second row smallest element is 8 and second smallest 10. So the penalty is 2. And in third row smallest 8 and second smallest 11. So the difference of 8 and 11 is 3. So penalty is 3. And in now we find the penalties of each column. In first column smallest is 6 and second smallest is 11. So the difference of 6 and 11 is 5. So penalties is 5. Now in second column smallest 8 and second smallest 10. So the difference of 10 and 8 is 2. So penalty of this column is 2. In next column smallest 8 and second smallest 13. So the difference of 8 and 13 is 5. So the penalty for this row is this column is 5. Now we check the highest penalty. So here highest penalty is 5, but 5 is right here in two places. So we select any one. Here we select 5. So enter in this column. We check the smallest cost cell entry. So here smallest cost cell entry is 6. For this 6 availability of demand is 5 and supply is 25. So now we allocate here minimum of 5 and 25. So minimum of 5 and 25 is 5. So allocate here 5. So this become 5 minus 5 0 and 25 minus 5 20. So the demand of market M2 is remaining 0. So now cross out this. Now move the next table. So the reduced table is M3, M4, P1, P2 and P4. 8, 13, 10, 8, 13, 8 and demand is 105 and demand is 20. Here supply is 20, 55 and 50. Now we again find the penalties of each row and each column. Here in first row smallest is 8 and second smallest 13. So the difference of 8 and 13 is 5. So penalty is 5. In second row smallest 8 and second smallest is 10. So the difference of 8 and 10 is 2. So the penalty is 2. And in third row smallest 8 and second smallest 13, difference is 5. So penalty is 5. Similarly we find the penalties of each column. In first column smallest is 8 and second smallest 13. So difference 8 and second smallest is 10. So the difference of 8 and 10 is 2. So write the penalty here. Second column smallest is 8 and second smallest 13. Difference is 5. So write here. Now we check the highest penalty. Here highest penalty is 5, but 5 right here in 3 places. We choose any 5. So here we select this 5. For this 5, now we select any 5. So we select this 5. For this 5 here enter in this row. So we select the smallest cost entry cell. Here smallest cost entry cell is 8. For this cost entry cell, the availability of demand is 105 and supply is 20. So we allocate here minimum of 20 and 105. So minimum of 20 and 105 is 20. So right, allocate here 20. So subtract 20 minus 20 remaining 0 and 105 minus 20 85 remaining. So the supply of plant P1 is remaining 0. So now cross out plant P1. Now the reduced matrix is here plant P2 and P4, market M3 and M4. 10, 8, 13, 8 and demand 85, 20, supply 55 and 50. So again we find the penalties of each row and each column similar to discussed in previous table. So here penalty of first row is 10, smallest 8 and second smallest 10. Here only two elements, so one is smallest and second is second smallest, so difference is 2 and here difference is 13, 5, here difference is 3 and here difference is 0. So now we check the highest penalty. Here highest penalty is 5. So enter in this row. We select the smallest cost entry cell. Here smallest cost entry cell is 8. So now allocate here minimum of demand and supply. Demand is 20 and supply is 50. So minimum of 20 and 50 is 20. So allocate here 20. Now subtract 20 minus 20, 0 and 50 minus 20, 30. So the demand of market M4 is remaining 0. So cross out this. Now we move the next table. So here next table is market M3 and P2, P4, 10, 13, 85 and here 55 and 30. So here only two elements are remaining. So here allocate 55 and here allocate 30. So our process of allocation are complete. Now we allocate these entries in the original table of the problem. So we move the original table. So this is our original table. So now here first we allocate here in P2 M5 15. So P2 M5. M5 0 0 0 0 and this is supply. So here first we allocate P2 M5 is 15, P2 M5 here is 15 and second is P3 M2 30, P3 M2 30, so allocate here 30. Next is P1 M1 is 25, P1 M1 is 25 and next is P1 M2 5, P1 M2 5 and next is P1 M3 20, P1 M3 is 20 and next is P4 M4 20, P4 M4 is 20 and next is P2 M3 55, P2 M3 55 and next is P4 M3 30, P4 M3 is 30. So now we find the total cost. So total cost is 25 into me 4 plus me 5 into 6 plus 20 into 8 plus 55 into 10 plus 15 into 0 plus 30 into 4 plus me 30 into 13 plus 20 into 8. Now 25 into 400 plus me 30 plus 160 plus 550 plus me 0 plus 120 plus me 390 plus me 160. So now add 100, 130, 130 plus 290, 290 plus 840, 840 plus 960, 960 plus 1350 plus में 160, 1000. So cost is 1510 rupees. So hope you student all are understand how to find the unbalanced, how to find the solution of unbalanced transportation problem. So in this scenario we are discuss, first we convert the unbalanced transportation problem, balanced transportation problem, and after then solve the Vogel's approximation method.